Okay, so in this video, we're going to take a first look at logarithms. Now, this is a complex topic, of course, but we're going to go nice and slow and just consider the understanding of what it really means, what these expressions in front of us right now are actually saying, okay? So a logarithm, well, if you look at it, okay, we've got this word log, we've got a little number, right, 10, and then we've got a larger number, okay? Now, a logarithm, just for today anyway, is going to be a way of explaining exponential notation, right? It's a new way of thinking about it. Now, I want you to think of it and read it, okay? I think this says to me, what is it that I need to raise 10 by in order to get 100,000? Right? Okay, so I want you to think about that expression. What is it I need to raise a 10 by, okay, in order to get 100,000? So perhaps I'm thinking of a equivalent expression, really. I'm saying 10 to the power of what, and I shouldn't really use question marks in math, but you get the idea, gives me the answer of 1,000. And of course, with tens, it's quite easy. Those zeros are you just have to count them, don't you? Well, of course, 10 to the power of 5 is 100,000. So that means that the answer to this, the equivalent to this, is 5, okay? Because that's the answer, that's the exponent, right? So this is a kind of way of thinking about exponents, right? And it's just about changing the notation. And we're going to go a lot further with this, and we'll see this idea in different ways later on in the video series. But for now, let's just start off like that. So let's think about these, right? And I'm going to go through these with you and see if you can think and get them right. Right, okay, let's go on to B. So read this as I did. What is it I need to raise 10 by in order to get the answer 0.01? So again, 10 to the power of what gives me 0.01? Well, 0.01 is the same as 1 over 100. And 1 over 100, well, that is going to be 10 to the minus 2. So this one here, look, is minus 2. Let's move on. What about C? What is it I need to raise the 3 by to get root of 3? Well, square root is like having 3 to the power of a half. So that answer is a half. I think D is a really simple one to get us to understand this. Take a look at D. What is it I need to raise a 2 by in order to get 8? Well, of course, it's 3. 2 cubed, okay, 2 times 2 times 2 gives us an 8. Let's carry on. What is it I need to raise 2 by in order to get 64? Well, 2 to the power of 4, maybe you know that one is 16. 2 to the power of 5 is 32. 2 to the power of 6 is 64. So therefore, this is going to be 6, right? And so, of course, if we know that one, maybe we can do F already. Because, of course, if that's the case, 2 to the 7 is going to be 128. This one's going to be 7, isn't it? Okay, what about G? Log 5, 25. Say it to yourself. What is it you raise 5 by to get 25? Well, of course, it is going to be 2. Ooh. H, have you got it already? Hopefully you have. It's 3. Okay, so let's move on. Let's try a couple of more challenging ones. I'm not going to go through all of these. I'm just going to draw out some ideas for you, okay? So the first one I want to take a quick look at is K, right? Okay, let's have a look at K. So log, and we say base M, M cubed. So to me, this reads, what is it I need to raise M by to get M cubed? Well, surely here the answer's in the question. It's 3, isn't it? The answer is literally staring us in the face. What I need to raise M by to get M cubed is it's cubing it, right? It's a 3. So just bear that one in mind. Let's take a quick look at L here as well, because this one looks a little more complicated, doesn't it? What is it I need to raise X by to get X root X? So really, actually, what we're doing here is we need to convert X root X to an exponential equivalent, right? So that's X to the 1 multiplied by X to the half, right? Because X is X to the 1, and the square root of X is X to the half. Well, so this is going to be X to the 3 over 2, right? Because I can add those powers together when I'm multiplying with the same base. base. So maybe it's easier to rewrite this. Log base x, x to the 3 over 2. And I'm going to say my catchphrase again. What is it I raise x by to get x to the power of 3 over 2? 3 over 2, of course. Okay, so that's how we understand these logarithms. Right. Now then, so now we've got that understood, maybe we could change these exponential expressions into logarithmic ones, right? So let's take d for a starting point, okay? We all know that 7 squared is 49. It means 7 times 7. So the equivalent logarithmic expression would be log the base 7, 49 is equal to 2. Now let's just read that to ourselves and check. What is it I raise 7 by to get the answer 49? I raise it to the power of 2. That works, doesn't it? So that is our equivalent exponential, logarithmic equation. Let's do one more. 3 to the minus 3 is 1 over 27. What is it I need to raise 3 by to get 1 over 27? Of course, it's minus 3. So that's what's happening here. And just to show you the other way around, can we convert these expressions, or some of these perhaps, into an exponential equation? Well, let's take an easy one to start with. Maybe we'll do a harder one in a minute. Let's look at e, log 283. What is it I raise 2 by to get 8? I raise it to the power of 3. So 2 cubed equals 8 would be the equivalent exponential. Let's just carry on, do one more, maybe h. So what is it I raise 3 by to get the root of 27? 1.5. 3 to the 1.5 equals root of 27. Okay, hopefully this little video has helped you to understand an introduction to logarithms, just viewing it as some notation and an interesting way that we can rephrase exponential